Good morning, Nasser. I'm going over this is the plan comparison. I'm going to give you a couple of clues and hints and teacher orders. Number one, please put the homework assignment number and the name on each one so I can not get confused. I'm old, I get easily confused. So this is your plan comparison. So there were four different groups, right? A placebo, one group got a little, medium, high. This is their numbers. These are their means. So far, so good. Standard deviations, errors, standard errors, and their confidence intervals. Okay. So gives the mins and the max of each group. Right. I can already you can tell by looking at it that there's going to be a significance difference in here somewhere. So here's our testing the homogeneity of variance with the Levene's test. And we're good to go. We did not violate the assumption of homogeneity variance because this number is greater than 0.05. Okay, so we're good to go. So it did an ANOVA between all the groups, which is fine, okay, but we're going to do the plan comparisons. We're doing it ahead of time, but the computer did this automatically, and there is a significant difference in there somewhere. So let's look at our contrast coefficients. This tells me that you're planning to compare the placebo as one group versus the sum of these three groups. Okay, that's what these coefficients tell me. Boom. So your second comparison tells me that you're comparing the minimum versus the medium. And the third comparison is the medium versus the high. Okay, this is how you interpret these. So here is comparison number one, right? The placebo against everybody else. Huge value contrast. What that does is it takes the mean of your one group and the new mean of your second made up group, and it subtracts them. That's all it's doing. And there's a huge t-score, which gives us a very small p-value down here. Okay, so Microsoft Word had to split this table. But that tells me that there's a significant difference in your first comparison. Not in your second comparison, right? That's a very small t. That is not a small significance value. But there was in your third comparison, okay? That's less than 0.05, and there's the t-score for that. Okay, so you had a significant difference in your first comparison and your third comparison, but not your second. So let's see how you wrote that up. Means plots kind of agree, right? There's the placebo. There's the high. Not much difference between the two in the middle. Okay, plan comparison was conducted to compare the results of the different drug. The patients were ran in four groups, placebo, blah, 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 blah. Okay, so far so good. Okay, so based on the data, the test, there is a significant difference. Let me fix that for you. Difference between placebo and the other. Oops. Hold on. And the other three groups. That's fine. But now here's APA formatting. Whenever you use the word significant, you have to put in the t-test score, okay? So you said there was a significant difference between the placebo and the other three groups, which is perfect. So now let's go up and get our t-score that proves that. So that was our comparison number one. There's our t-score right there, right? Negative 4.98. So you got to go back to your AP write-up and put in comma, t, parentheses, how many degrees of freedom. I'm going to go up and check real quick. And the actual t-test statistic, which was 4.99. It doesn't have to be negative. In fact, do not make it negative. Just use the absolute value. SPSS does not do that for some strange reason, but we know. So I'm going to go back up and look for the degrees of freedom. That's basically how many people were in the study. So degrees of freedom, that's everybody in the study right there, minus the number of groups. So we had 25 people in the study. Okay, so that's going to be our degrees of freedom. 25 equals that. And then you got to put in the p-value is less than, I'm just going to say 0.05 because that's the standard that we're kind of using now. Okay, see that? Bam. Wasn't that nice? Yay. So there was also a significant difference. Again, there's that word significance between medium and low. So you got to do the same thing. I'm just going to cut and paste this and put it after that sentence. So I'm going to go back up and get the data for the third comparison. So it's negative 2.61. And let's see what our degrees of freedom are. So there's only 22 in this one. So the degrees of freedom from that last comparison is just the minimum versus the median. So I would say it's 7 plus 6 is 13 minus the 2 would be 11. But I noticed that the SPSS doubled that to 22, and I'm not sure why. So I'm just going to put whatever SPSS says because that's what people are going to look at. So let's just say that I can't live with that. So I'm going to put 11 here. And it was, 2.661, which again gave us a little tiny point p-value. But that's it, okay? So remember, whenever you use the word significant, you got to put in the actual t-scores, degrees of freedom, p-values, that kind of stuff. So, but the rest of this looks really, really good. So I'm going to look at your homework 7, your within group ANOVA. So here's the data. So they're trying to see if the sexual harassment training is effective at reducing the number of those kind of complaints. So this is the pre-test here, right? They did all 7 divisions, and then they did 4 weeks of training, and then they did a 6-month follow-up. So what's important here is everybody got every training. Okay, that's what makes it a within group or a repeated measures ANOVA. So let's see what you did. Again, if I could get you to put like homework number 7. And then label it so I don't get confused. Okay, so put that on all your homeworks. So let's take a look. So here's our 5 different groups. 1, 2, 3, actually 6, right? 6 different times these guys were measured. These divisions were measured, I guess. Here's the means of all the different weeks. And what I do is I look at the lowest, 54, and then I look at the highest. What's the highest? 67, and that's 13. Wow. So the difference between the highest and the lowest is 13, and then I look at the standard deviations. They're somewhere around 6 or 7, and 13 is almost 2.7. So that tells me that there's probably going to be a significant difference in there somewhere. But that's just me. So some books tell you to look at the Wilks lambda. Okay, right off the bat. So we got a significance of less than 0.05. So I'm assuming that our within subjects ANOVA is going to have not the same numbers, but the same outcome. Okay, so I'm expecting there's going to be a significant difference in there somewhere, according to the Wilks lambda. Okay, let's just keep going. So one of the assumptions of a within group ANOVA is sphericity, and you did not break that, right? So the Mauchly's test of sphericity proves that we satisfied the assumption of sphericity of the data. And just as a sidebar, if the Mauchly test, if this is less than 0.05, there's a correction you can make to the data, and it's called the greenhouse geyser effect. And without going into a lot of detail, there is ways to get around the sphericity assumption, within limits. Okay, so here's your within group ANOVA. And bam, yeah, you got a giant F here, and your significance is much less than 0.05. So yes, there is a significant difference in there somewhere. And your eta squared, which is your effect size, is pretty darn big. It's almost 90%. So in other words, 90% of the variance within the different within the different number of complaints filed, 90% of them can be attributed by the different groups they had there, okay? And your power is perfect. So it means you got a real good test, okay? But again, here's your within subjects contrast. Remember, contrasts are planned comparisons. The computer automatically does this, so we don't have to worry about that. So we don't worry about it between subjects because this is a within subjects design. And don't need that. Marginal means, don't need that really either. So let's take a look at your write-up. Within group ANOVA test was to measure effectiveness as a 4-week concentrated good. Harassment reports were measured and recorded a week before the program, during the 4 weeks training, and a week after the program. Okay, so this is the post. Oops. This is the post and this is the pre. Okay, that's good. Based on the data from the result of the test, let me advance that down a little bit. There was a significant difference. Before and after the training program. Okay, so you use the word significant. So now you got to do something about it. So hold on. And I found an error in my teaching. I did not teach you guys how to find the degrees of freedom within group study. I apologize for that. But within group study, your degrees of freedom that you're going to look for on your ANOVA table is this one, the between groups degrees of freedom, but your second one is your error term degrees of freedom. Okay, so for our problem, so our between group degrees of freedom, that's the number of measurements we made. So 6 minus 1 is going to be 5. The number in each group was 7, right? So there's 7 divisions. So the total number here within group is going to be the number of groups minus 1, which is 6 minus 1, times the number of individuals in each group minus 1. So 7 minus 1. So our within group total degrees of freedom, kind of complicated, is 6 minus 1, which is 5, times 7 minus 1, which is 6. So 6 times 5 is 30. Okay, so that goes there. Now let's go back to the table and get our F score. No, we want our within subject score. Where is that? There it is right there. Boom. So looks like 97.3, which is huge. 97.3. And again, the p-value is tiny. So that should do it for now. I hope this helps. I'm going to go ahead and send within group degrees of freedom quickie tutorial to everybody later, plus this upcoming week's assignment, which includes the test, the midterm. There's 2 midterm multiple choice online, plus you're going to have a bunch of assignments. But I'll send that out tomorrow. So I will talk to you soon.